welcome you all in this new video. And today video is going to be very interesting because in this video we are going to understand the Maxwell's equations. In this video we will discuss only the one equation, which is the first equation, okay, and later on the another videos we will discuss the remaining. Okay, so why it is important for us to understand the Maxwell's equations, and we can correlate it with the phenomena that Newton provide three laws. Okay, we can say fundamental law of the mechanics or fundamental law of the nature, and the laws provided by the Newton, they are basis of the whole mechanics. Okay, and similarly Maxwell's equation provide us the fundamental base for to understand the electromagnetism, which further leads to invention, or we can say unlock the properties of electromagnetic wave. And because of the unlocking of the electromagnetic properties after the Maxwell's equations, okay, they provide us today, we are able to use that electromagnetic waves in our real life, like in communication sector, in we can say medical sector, okay, in the study of the galaxy, study of the stars, everywhere we use electromagnetic waves. And all this was possible because of the Maxwell's equations, because this provide the fundamental base. Okay, and I think after the 20 or something 18 or 20 years later, this experiment or these equation was physically proved, experimentally proved, okay, by the Hertz, named scientist Hertz, okay, and they provide us the practical significance of the Maxwell's equation. And after the practical and after the experimental verification by the Hertz of the Maxwell's equation, provide a way further for the invention of the electromagnetic wave, and to invent the further minor properties of the electromagnetic wave that we can use in our real life. Okay, so the concept here is, overall the Maxwell gave us four equations, and those four equations are very important. We will discuss in another video, and how we are going to use that in electromagnetic wave, and how we are going to use that to determine or to calculate everything regarding the electromagnetic wave. So first of all, we have to understand the Maxwell's equation. Okay, let's understand. So first is Maxwell's first equation. Maxwell provided us four equations. So in this video we are going to discuss only the one equation, okay, and that is called, and these are called with the name, okay, Maxwell first equation. Okay, so Maxwell, what he used, he combined, or he it is like a amalgamation, we can say. He used the Faraday's law, he used the Ampere circuital law, he used the Gauss theorem, okay, all these laws he used, and on the basis of that he derived another equation. It means we can easily say Maxwell's equation are nothing, it is just a modification of the laws, okay, like which was present, like Faraday's law. Faraday's law also deals with the electromagnetism, but it was not at that correct, okay. We can say the correction was provided to that laws through the Maxwell's equations. Okay, so Ampere's law, Faraday's law says what? It says that we can say changing magnetic flux produce the current, or changing magnetic flux produce the EMF. Okay, means electromotive force is provided by the change in the magnetic flux. Faraday's law says that. Ampere law says that change in the, we can say, electric flux is equal to the permeability times the current flowing through that a particular conductor. Okay, there was a Gauss law, you already know, regarding the electrostatics. Okay, so we can say Maxwell's equation were nothing, these are just modification of the Faraday's law, Ampere's law, Gauss law. Okay, so okay, first equation is the Maxwell first equation, and I want to assure you that in this equation he used the Faraday's law. We can say he used the Faraday's law for the modification, okay, so that it can be applied anywhere. Okay, it further leads to the unlocking of the various properties of the electromagnetic wave. We will discuss that later. Okay, first of all, understand how Maxwell used the Faraday's law. Okay, so what does the Faraday's law say? Faraday's law. Okay, Faraday's law says that electromotive force, okay, produced in a particular conductor is what? it is the rate of change of the magnetic flux within that. Means here is your conductor, okay, and you are providing the magnetic field like this, okay, like this, and the magnetic field flux means what? It is the flux means the magnetic field passing through a particular surface in a particular instant of time. Okay, let's say here is a surface, and how much magnetic field lines are passing through this surface in a particular instant of time. Okay, that is called magnetic flux. So this is denoted by phi. Okay, now what is the electric flux? This is surface integral, because we are talking about, it can be anywhere, it can be line integral, it can be surface integral, it can be volume integral. Okay, but we are talking specially regarding the surface integral. Okay, so what is the flux? Flux means passing, how much magnetic field lines are passing through a particular surface. Okay, so it means that B and ds. Okay, so this is our magnetic flux. If we put the values here, so it will become B vector. And what is this B? Don't be confused. B means magnetic field, okay, and ds means area through which that magnetic field lines are passing. Okay, if we do it further, and it will become minus, here is also surface integral, don't miss it, okay, here. So it will become surface integral of the dB over dt and ds. Okay, and here is what? It is electromotive force. So this is the equation that we got. It is very easy. You just have to correlate the concept and adjustment, okay, and substitute the concept. Okay, so it is very easy. So this is the electromotive force. Now we have to replace the electromotive force with the electric field. Why? Because here we are going to discuss what? We are going to discuss the relation and how the changing magnetic field and electric field change correlate with each other. Okay, so we have to now derive. So what was the equation? Let me write. This was surface integral, and this is the rate of change of the magnetic field with respect to the time, and ds. Okay, now what is this? This is electromotive force. And if we talk about if, okay, if E is the electric field for us, okay, E is the electric field strength. So what is the electromotive force? Electromotive force is nothing, it is the line integral, closed surface line integral of the magnetic field, okay, sorry, electric field. So this is our electromotive force, because we put this concept, or we pick this concept from the electric field strength. Okay, and we know that this formula. Okay, so now replacing this formula in this, so we will get EDL is equal to minus, don't be confused, okay, and this is curly T O with multiplication ds. Okay, so now we know that, okay, we know that what is the Stokes theorem? Stokes theorem and Gauss theorem, these are related with the curl and divergence, okay, of the electric field and magnetic field. These are applicable on all the things. What is the Stokes theorems? It says that if a particular electric field in a closed line integral, okay, that will be equal to the surface integral of the curl of that particular field. Okay, because we are talking about here electric field, so put here electric field. Okay, Stokes theorem doesn't mean that it only deals with the electric field, okay, it deals with every kind of the fields, okay, but this formula should be constant there. Okay, so it said that if electric field is in the closed integral, okay, line integral, and that will be equal to what? Curl of the that particular field and with the surface integral. Okay, so by putting this value here, we will get E, okay, and ds is equal to minus, I am putting it in a standard differentiation, okay, dt ds. Okay, now if we can cancel the here surface integral from here. Okay, so finally we got, okay, and equal to minus, okay, it is the change of the magnetic field. Okay, so this is our first equation of the Maxwell laws. And what is the significance? Let's understand its significance, or what is it. Okay, what we get, we got the, okay, and equal to minus curly b over curly t. So what does this mean? It means that your electric field is changing with respect to the change in the magnetic field. Okay, so it is telling us, and it is reflecting the idea of electromagnetism, how there is change. Okay, and how the if what happened if there is change in the magnetic field with respect to the time in a particular region. Okay, like let's say here is a region, and electric field lines, or we can say electric field intensity, is decreasing with respect to time, or increasing or changing with respect to the time. Okay, so it will give rise to what? Electric field, where if here is a particular conductor. Okay, it will give rise to electric field. What does the electric field means? It means that it will provide us the in the form of current. Okay, so there will be some electromotive force, and electromotive force will lead to the formation of current in that particular circuit, or it can be any kind of the conductor. Okay, so this is the Maxwell's first equation. I hope you like this video, and remaining equation we will discuss in the next video.